We're going to talk about functions in chapter 4 and inverses of functions. So when we talk about an inverse of a function, we are talking about a way to undo the function. Whatever f has done, that we're going to be able to undo it and go back to where we started. Okay, so an example would be if tying my shoes is my function, then untying them would be the inverse of that function. So if we look at a diagram here and say the blob on the left is the domain of our function f, and the blob on the right is the range. And maybe f of x takes a to b. So one way we could write this, remember, is saying f of a is equal to b. Or we could say the ordered pair a comma b is a point on the graph if I wanted to draw a graph of this function. But maybe f also takes c to b. Now remember, this is still a function by definition. A function means that the x's don't repeat, and since there's only one arrow leaving each x value here, going over to the right to the y, then we know that f really is a function. However, if I wanted to undo this function, I wanted to go backwards and unwind things and follow the path back to where I began. If I just blindfolded you and drove you to B and dropped you off, took off the blindfold and said, now go back to where you came from, it's unclear which path you would need to take. Okay, there's two paths away from B, and I don't know which one I started with. What that means, and in this example, this means that f is not going to have an inverse. So we need to make a definition. F is what we call a one-to-one function. F is one-to-one. If for each y in the range there is only one x that gets you there. Each y in the range, for each y in the range, there's only one x that takes you there. Okay, and this is my definition. This isn't formal mathematics definition, but it will say that in nicer terms in your book in one of the boxes. Okay, there can only be one path if I want to go backwards. Every y in my range, there can only be one path that leads there, okay, which means this picture that we've drawn, this function is not one-to-one. Okay. If I eliminate this guy here, okay, now we're okay. Now that function is one-to-one. So then the next thing that we'll say is f of x has an inverse if and only if it is one-to-one. Okay, a function has an inverse if and only if it is one-to-one. Okay, yes, I know I wrote the word if with two f's there. When I write that, and we're going to start seeing this a lot in chapter 4, it means if and only if. Now, an if and only if statement is something we really haven't worked with yet this semester. It's a little bit different than our normal if-then statements. A lot of our theories, our theorems, only can be read in one direction. If and only if is special because it can be read forwards and backwards and still be true. Okay. Meaning if I know that f is a function that has an inverse, that means it has to be one-to-one. Or if f is a one-to-one function, then I know by default that it has an inverse. And a lot of you think, oh, Ms. Jackson, a lot of the things that we do work that way, but they don't. Okay, the example that I can give you is kind of boring, but I was born in Winfield, Kansas. Sorry, I was born in Winfield. Okay, which if I walk up and say, hi, I'm from Winfield, then you know that implies that I'm from Kansas. But if I walk up to you and say, hi, I was born in Kansas, Does that automatically take you back to my hometown? Okay. So that example there, not an if and only if statement. Being born in Winfield, it can only be read in one direction. Being born in Winfield means I'm from Kansas, but being from Kansas, I could be born in a number of different places. Okay. So we really like if and only if statements. Again, chapter 4 is really the first place we focused on those. And a function has to be one-to-one if we're going to be able to undo it, unwind it, unwrap it, and be able to work in the backwards direction. So maybe I'm looking at a picture. And I say I want to know if these functions have inverses. Okay. If I'm standing at a value of y in the range, this parabola here has a range from 0 to infinity. Okay. So if I'm standing at this y value on my graph and I want to figure out how many x's took me there. Okay. Notice there are two x values, one here on the left and one here on the right, and those two different x values took me to that same y. And so just from that point alone, I can say, well, this function is not one-to-one. Understand that both of these pictures up here on the board, both of them are functions. And to determine whether or not it's a function, what did we do? Vertical line test. So when we drew our lines vertically throughout, okay, each one that I draw only crosses in one place. Okay, so I know that both of those guys are functions. Okay, we're not going against that. The one on the left, this parabola here, is not a one-to-one function. Okay, if I play for a minute with the right function there, okay, for this particular value of y, there's only one x that takes me there. If I'm up here at this particular value of y, looks like only one x that takes me there. And no matter where I try to stand, whether I'm way up high, whether I'm way down low, okay, there's only going to be one x that takes me to each of those y's. Overall, in general, if I'm looking at a picture, hopefully it's kind of standing out to you at this point. But what I can do, similar to what I just did with the yellow line I erased, we can turn that line in a different direction and do the horizontal line test. Okay. Back in chapter 2, when I said don't just tell me things like I did the line test, because there's going to be others, here's our other one. Okay, the vertical line told me that it was a function. Okay, this is a function, that's a function. But if I make that line horizontal now, if I can draw even one horizontal line that intersects 2 or more times on my graph, then I know it's not a one-to-one function. Okay, still a function, it's just not one-to-one. Over here on the right, no matter where I slide this horizontal line up and down, each one only intersects the blue graph in one place. Okay, so on the left, parabolas, those are nice functions. We usually like to mess with them if we've moved past lines, but not a one-to-one function. A function that is not one-to-one means no inverse exists. Okay. This guy on the right is going to have an inverse. Okay. Next video, we're going to pick up with some more details of that, but I want to keep this kind of short.